Sorry about the abrupt stop to the last video, but it actually would have run out of time. So, example 6. Differentiate, again, f of x is x cubed minus 3x plus 2. Probably the first thing that should come to mind when you're differentiating is this in a nice format? Do I have to make any changes to it? And the answer is no, because we've got a power, there's no x in the denominator, there are no square root sign. It's all fine, so we can differentiate it. Secondly, think about what the function is. This function is a cubic. You'll have a bit of an idea about cubics by now because you've seen me commonly say there's really two styles. Oh, I guess there's three styles. The moment you introduce other x terms, so when it's not just x cubed, because if it was just x cubed, the graph looks like that. So when you've introduced other terms into the function, it's either one of those, and it'll be that if the coefficient of the x cubed is a positive number, which it is. Otherwise, it's this one. Now, what we know is that it has two turning points. It has two turning points. So does this one. This one doesn't. This one, we'll see later, has a special turning point. And it only has one turning point. So the question goes on to say, and find the 2 points where the curve turns. In another chapter, there's many exercises on finding turning points, identifying turning points. So this is a nice little introduction to what we're going to do a whole lot more work on, in that we're finding the turning points. Now, at any turning point, the gradient of the tangent is 0. So we're finding turning points. So we'll have two lots of x and y, two lots of x and y. I could have called those 1 and 1 and x2 and y2 for my 2 points. So I know what my answer should look like. By reading this question, I've got an idea that of what my answers are going to will look like. And so hopefully that stops me from thinking I'm finished halfway through. And I'll point out what that halfway through point actually is. So I'm differentiating, yes, no problem at all. The simple little pattern. I've got my derivative. I've got my expression for the tangent. I know the tangent needs to be 0. Yes, the gradient function has to equal 0. I've got an expression for the gradient. It's this 3x squared minus 3 has to be 0. So I can solve for x. I can at least find the x spot where the gradient will be 0. Interestingly, the expression for the gradient is a quadratic. When we solve a quadratic equal to 0, we most commonly get 2 answers. We learned that about a quadratic. So this is nicely making sense. I've got a quadratic, I'm solving it equal to 0. I'll get 2 x values. Explains why they said find 2 points. I now have at this stage my x1 and my x2. My x1 will be 1 and my x2 will be -1. Now, at that point, many students think they're finished. They've found 2 x values, however, we have not found 2 points, because we all know a point has an x and a y ordinate. So the rest of our solution is just finding the y values for the 2 points. So when x is 1, what is the y value? You go back to your original function to get your y value. You don't go over here. This is all about gradient. This is about the y value. And we've got that 0, 0 when we sub those in, when we sub x equal 1 in. And then when we sub x equal, so I can conclude 0, 0 is a turning point. Identify it. It's part of my answer. And also at x is minus 1, I'm getting y is equal to 4. Therefore, my conclusion is at x is minus 1, y is 4 is also a turning point. Let's just see how we go compared to the graph. So, what have I done wrong? I don't have, oh yes I do, sorry. I have minus 1, 4, which was this one, and I've written that incorrectly, haven't I? It was at 1, 0, sorry, that was my mistake. At 1 and 0 is a turning point. Hopefully if I did that under pressure in an exam, because I'm actually saying when x is 1, y is 0, that error would have been overlooked. Because I've clearly said I'm working with the knowledge that x is 1 and I've got y is 0. They may see that as a transcript error. I'm pretty sure you would still get the marks for it if your setting out had that much explanation in it. So, back to the graph. At x is 1, yes, y is 0. And that is a turning point. They're definite turning points. The graph goes from coming down to turns and it goes up. Here the graph is going up, but it stops and turns and comes down. So you can see why they're called turning points, I hope. I think that's about it. And hopefully you're right now to do some questions from exercise 7C.